Hello good day viewers. In this tutorial we are going to find a solution to this nice Diophantine equation. This question was posted by Isa Garba, who happens to be a member in Tumble Maths class Facebook group. Alright, let's get started. We asked to solve the equation x raised to the power of y minus y to the power of x equal to 17. Okay, we are going to play some logics here. First of all, naturally any value raised to the power of 1 will not change it, right? So we have x raised to the power of y also raised to the power of 1 minus y raised to the power of x also raised to the power of 1. This remains 17. But I know that 1 is the same thing as 2 divided by 2 for a reason. So I'm going to replace this 1 with 2 divided by 2. 2 divided by 2. 2 divided by 2 is 1. I want to use 2 because I know it will give us difference of 2 squares. And from here, we may decide to take the denominator inside. These two denominators, we are going to take them inside according to one of the laws of indices. So this will give us x raised to the power of y multiplied by 1 over 2, right? But raised to the power of 2. If you multiply this together, you're still going to get 2 divided by 2 minus y to the power of x multiplied by 1 divided by 2 raised to the power of 2. This is equal to 17. And if you multiply these two exponents, you're going to get y divided by 2, and this is x divided by 2. Therefore, we can write it properly. X raised to the power of y divided by 2 here, all raised to the power of 2, minus y raised to the power of x divided by 2, also raised to the power of 2. And this is equal to 17. And this is nothing but difference of 2 squares. What can you remember about difference of 2 squares? Suppose we have a raised to the power of 2 minus b raised to the power of 2. This is equal to a plus b, then multiplied by a minus b, if you want to factorize it. So we can apply the same thing where a represent x to the power of y divided by 2 and b represent y to the power of x divided by 2. So we have the whole of this plus this, which is going to give us what? X raised to the power of y divided by 2, then plus y raised to the power of x divided by 2. Then we multiply. This time around, we take this, we subtract this. We have x raised to the power of y divided by 2 minus y raised to the power of x divided by 2. And the whole of this equal to 17. Now we have two factors. This time this equal to 17. And 17 is a prime number. It has only two factors, 1 and itself, right? So 1 times 17 is the same thing as 17. And you should know that this value right here must be greater than this one because this is addition while this is subtraction. We can represent this with 17 and this with 1. If you multiply them together, you're still going to get 17. So now let us form a system of equations here. We have x raised to the power of y over 2, then plus y raised to the power of x over 2. This should be equal to 17. And the other factor, which is x raised to the power of y divided by 2 minus y raised to the power of x divided by 2 should be equal to 1. What are we going to do? Let us add these two equations together so that we can eliminate one of the variables. If you add this, because they are like terms, you have two quantities, right? So we have two quantities of x raised to the power of y divided by 2. But this will give us 0 if you add them together because one is positive and the other one is negative. This is equal to 17 plus 1, which is 18. And you can divide both sides by 2 such that x raised to the power of y divided by 2 is now equal to 9. If you want to get rid of this 2, you can square both sides. So x raised to the power of y will be equal to 9 squared. You square the left hand side, 2 will cancel 2, you have to square the other side. And this implies that x raised to the power of y is equal to 81. We know that 3 raised to the power of 4 is 81, right? So we can say that x raised to the power of y is equal to 3 raised to the power of 4. Now let us go back to the other one. Remember that we added these two equations, right? So these are the equations. This time around, I would like to subtract just to eliminate this. You know, if you subtract this minus this will give us 0, and this minus this will become plus. We have two quantities of y raised to the power of what, x divided by 2, and this is equal to 17 minus 1, which is 16. Divide both sides by 2, you have y to the power of x divided by 2 to be equal to 16 divided by 2 is 8. And if you square both sides, you have y to the power of x to be equal to 8 to the power of 2, and y to the power of x equal to 64. But 64 is the same thing as 4 raised to the power of 3. So y to the power of x is equal to 4 to the power of 3. Okay, now let us relate these two equations together, this and this. What can you deduce here? Let me bring them together. We have x raised to the power of y to be equal to 3 raised to the power of 4. Then we have y to the power of x to be equal to 4 to the power of 3. If you observe these two equations together carefully, x is the base here, while 3 is the base here. Can you see they correspond? Y is the exponent, which is equivalent to 4. But look at the second equation. Y is the base, 4 is the base. X is the exponent, while 3 is the exponent. So you can see that x must be equal to 3 and y must be equal to 4, right? Therefore, x equal to 3 while y equal to 4. But if you doubt, you can always check this solution in the main equation. And what is the main equation? The main equation is x to the power of y minus y to the power of x equal to 17. So let me just copy that, substitute the values, and see whether we are going to get 17, which is to the right hand side. So let's substitute. If x is 3, we have 3 to the power of y, which is 4, minus y is what, 4 to the power of x, which is what, 3. And we know that 3 to the power of 4 is 81, minus 4 to the power of 3 is 64. Is this the same thing as 17? That is the question mark. And definitely 81 minus 64 is 17, and 17 equal to 17, and hence the solution to this problem is x equal to 3 and y equal to 4. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.